Welcome to our channel. Our topic for today is operations on functions. Here, instead of applying operations on numbers, we'll apply the basic operations on functions. First, we have the sum of functions. Let f and g be functions. The sum f plus g of the functions is f plus g of x equal to f of x plus g of x. Now let's have some example. Consider the functions f of x equals x plus 3 and g of x equals to 3x minus 1. From the definition of the sum, we have f plus g of x equal to f of x plus g of x. Substituting the values of f and g, we have x plus 3 plus 3x minus 1. Adding the same terms, we have f plus g of x equals to 4x plus 2. Next example, consider m of x equals to negative x plus 1 and n of x equals to 3x squared plus x minus 1. From the definition of sum, we have m plus n of x equals to mx plus n of x. Substituting the values of m and n, we have negative x plus 1 plus 3x squared plus x minus 1. Thus, we have m plus n of x equals to 3x squared. Now, let us define the difference of functions. Let f and g be functions. The difference f minus g of the functions is f minus g of x equals to f of x minus g of x. For the example, suppose f of x equals 3x minus 5 and gx equals negative 2x plus 2. By definition of difference, we have f minus g of x equals f of x minus g of x. Substituting the values of f and g, we have 3x minus 5 minus the quantity negative 2x plus 2. Thus, we have f minus g of x equals 5x minus 7. Now, let us consider the following. Let f of x equals x squared minus x plus 1 and g of x equals negative 2x plus 5. By definition of difference, we have f minus g of x equals f of x minus g of x. Substituting the values of f and g, we have x squared minus x plus 1 minus the quantity negative 2x plus 5. Combining similar terms, we have f minus g of x equals x squared plus x minus 4. Next, we have the product of functions. Let f and g be functions. The product fg of the functions is fg of x equals f of x multiplied by g of x. For the example, consider f of x equals x plus 1 and g of x equals x minus 1. By definition of product, we have fg of x equals f of x times g of x. Substituting the values of f and g, we have the quantity x plus 1 multiplied by the quantity x minus 1. Using the FOIL method, we have fg of x equals x squared minus 1. Now let's have another example. Let f of x equals x over 7 and g of x equals 21x cubed plus 7. By definition of product, f g of x equals f of x multiplied by g of x. Substituting the values of f and g, we have x over 7 multiplied by the quantity 21x cubed plus 7. Multiplying the terms, we have fg of x equals 3x raised to 4 plus x. Now, let us define the quotient of functions. Let f and g be functions. The quotient f over g of the functions is f over g of x equals f of x over g of x, provided that g of x is non-zero. For the example, consider the functions f of x equals x squared minus 2x plus 1 and g of x equals x minus 1. By definition, f over g of x equals f of x over g of x. Substituting the values of f and g, we have x squared minus 2x plus 1 over the quantity x minus 1. Note that the numerator is equivalent to the quantity x minus 1 squared. Thus we have f over g of x equals x minus 1. For another example, consider the functions f of x equals x minus 3 and g of x equals x squared minus 9. By definition, f over g of x equals f of x over g of x. Substituting the values of f and g, we have x minus 3 over the quantity x squared minus 9. Note that the denominator is equivalent to quantity x plus 3 multiplied by the quantity x minus 3. Thus we have f over g of x equals 1 over the quantity x plus 3. Finally, let us define composite functions. Let f and g be functions. The composite function of f and g is f of g of x. Note that f of g is different from f multiplied by g. For the example, let us consider the functions f of x equals x squared and g of x equals x minus 2. By definition, the composite function of f and g is f of g of x. Since g of x equals x minus 2, we have the quantity x minus 2 squared. Using FOIL method, we have f of g of x equals x squared minus 4x plus 4. For the last example, consider the functions f of x equals square root of the quantity x plus 4 and g of x equals x squared plus 4x. Note that the composition function of f and g is defined by f of g of x. Substituting the values of g of x, we have the square root of the quantity x squared plus 4x plus 4. Note that x squared plus 4x plus 4 equals quantity x plus 2 squared. Taking the square root, we have f of g of x equals x plus 2. And that ends our discussion. Thank you for listening.